This is question 14 from the SACE Stage 2 Physics course companion from Subtopic 2.5 Electromagnetic Induction. Here we have a transformer decreasing a voltage from 2.16 kilovolts to 240 volts. The transformer has 2,000 more turns in the primary coil than in the secondary coil. What we need to do is determine the number of turns in each coil. So let's write down some of the things we know. So to begin with, we have the voltage in the primary coil is 2.16 times 10 to the power 3, that's 2.16 kilovolts. The voltage in the secondary coil is 240 volts. Now we're going to let the number of turns in the secondary coil be X, and therefore the number of turns in the primary coil will be X plus 2,000, because it states that there are 2,000 more in the primary than in the secondary coil. Now it's just a matter of substituting those values into our expression for relating the voltages and number of turns in each coil. So we have 2.16 times 10 to the power of 3 over 240 equals X plus 2,000 over X. Now if we calculate 2.16 times 10 to the power of 3 divided by 240, we get 9, so 9 equals X plus 2,000 over X. Now we can multiply through by X to both sides, so we have times X, cancel out, so we have 9X equals X plus 2,000, and we subtract X from both sides. These cancel out, 9X take X is 8X equals 2,000, so X equals 2,000 divided by 8, which equals 250. Now we have to make sure that we answer the question. So we've worked out X, so the number of turns in the secondary coil is 250, and the number of turns in the primary coil is 2,000 plus 250, so 2,250, and that's it. So it's a little bit more complicated. There's a little bit of algebra in there, but nothing too difficult. It's just more of the same sort of concepts that we've been doing for transformers for the last couple of questions. They don't really get too much more difficult than this. This is all fairly straightforward.